Good day, wonderful students of Sleek Angels International School. I believe by now you are getting conversant with learning from your homes. Once again, my name is Aneke Victor, your mathematics and further mathematics teacher. In our last class, we discussed extensively on circle geometry. We discussed certain properties of a circle like the radius, the diameter, a chord, a sector, a segment, a tangent, and so many discussed. And in that class, I talked about so many circle theorems. We were able to handle about 3 of them. And I promised that in our next class, I was going to teach you more on circle theorems. My aim, remember, is to always make you recall and apply circle properties of angles subtended by a diameter, to make you recall and apply circle properties of angles subtended at the same segment, and recall and apply circle properties of angles formed by a tangent to a circle. In today's class, we'll be handling 3 of these circle theorems. And I have the first one here on the board, and it is angles in a semicircle. It is angles formed in a semicircle. I have a circle drawn here. I have another circle drawn here. I had the center of the circle as the dot I put there. If I draw a line from one end of this circle and cross the center to the other end of this circle, that line is called a diameter. We had said that in our first video. I urge those that haven't watched that video to do so as to be able to understand this section of the class. I have just drawn a line from one end of this circle to another, and that line crossed the center of the circle. That line is called a diameter. If I draw another line from one end of the diameter to touch the circumference of this circle, and then I join from this part down to this part, the angle formed here must be 90 degrees. You can try this at home. You can draw any circle, draw the diameter of the circle, and draw a line from one end of the diameter to touch any part of the circumference, and then draw another line from that part of the circumference to the other end of the diameter. The angle formed must be 90 degrees. I have another circle here. If I draw a line from this end to cross this diameter, to cross this center to the other end, the line, like I said earlier, is called a diameter. If I draw a line from this end down to this point, and I take it back here, the angle formed here must be equal to 90 degrees. So if I name this angle A, B, and C, angle A, B, C is always equal to 90 degrees. And the reason is short formed as semicircle when solving in an example or a test or an exam. I have another circle that I've drawn here, and I've been able to form the 90 degrees. If this line is X and this part is Y and this other part is Z, then X, Y, Z is also equal to 90 degrees, and the reason is still a semicircle. So the theorem states that an angle formed by a semicircle is always a right angle. An angle formed by the diameter of a circle is always a right angle. I have an example here written on the board, and in this example We were told to find the value of ACB. We were asked to find the angle formed at C. ACB, if you notice the indication on C, it means that the angle we're looking for is at C. Now, how will the theorem I just explained to us help us find the angle at C? Most questions do not necessarily tell you that the line drawn is a diameter, but you will just see this indication to show you that that point represents the center of a circle, because most wire questions are not necessarily drawn to scale, but yes, that indication will be put there to show that that line is the center of the circle. And when that line crosses the center of the circle, then that line represents the diameter. So in our question here, CB represents the diameter. And like I said, once a diameter is drawn, any line, any angle formed at this point, drawn from one end of the diameter to the circumference and down to the other end, that the angle formed here is 90 degrees. That is the first thing you will notice when you are about to solve this question. So the solution here is, you write that BAC is 90 degrees. So I write BAC to be equal to 90 degrees. The reason is a semicircle. Now that we've known the angle at A to be 90 degrees, it becomes possible to get the angle at C. It becomes possible to get the angle at C. Remember, ABC is still a triangle, and sum of angles in a triangle is 180 degrees. Since we've gotten this part to be 90, and we've gotten this part, and we had this part as 58, it becomes easy to get this part. So if you can add these two and subtract from 180, this angle will be gotten. Because the sum of this angle and this angle and this angle gives 180. So I quickly write that ACB is equal to 180 minus the sum of 90 and 58. The reason is sum of angles in a triangle. 90 plus 58 is 148. So I have 180 subtract 148, and my final answer is 32 degrees. We have just found the angle ACB to be equal to 32 degrees. We were able to get that because we just learned that the angle formed here is equal to 90 degrees. This angle would not have been gotten if we don't know this angle, because it takes you to know two sides of a triangle to be able to get the third side. I have a second example here which will also strengthen our knowledge of the angles formed by the diameter, or angles in a semicircle. Like I said earlier, this line drawn from this point to this end crosses the center of the circle. That means that this line is the diameter of the circle. This line being the diameter of the circle means that the angle formed here is equal to 90 degrees. Remember, it is easy for me to remove this line here and understand that the whole of the angle formed here is equal to 90 degrees. So For me to get the angle that is marked K, this part was given as 53. For me to get the angle that is marked K, I have to subtract 53 from 90. I have to subtract 53 from 90 because the angle formed at this point is 90 degrees. Most times, letterings are not given in the questions. Letterings outside the triangle are not usually given. The angle is lettered. So this question is asking us to find angle K and angle L. The question is find angle K and L. I've just said that K and 53 form 90 degrees because the angle there is equal to 90 degrees. So K becomes equal to 90 minus 53. And 90 minus 53 is 37. This reason is semicircle. You must always include your reason when dealing with circle geometry. I also have to find the angle at L. Remember, there was a line drawn here and the angle and this indication here was shown. This indication here shows that the angle formed here is also 90 degrees. We use this indication to represent 90 degrees. For this angle to be 90, it means that this other side here is also 90 because this line is a straight line. And sum of angles on a straight line is 90. We have just found K to be 37. If this is 37 and this is known to be 90, then it's possible to get L. If this is 37 and this is 90, then it becomes possible to get L. Because if you know two sides of a triangle, then you can always know the third side. So L becomes equal to 180 minus 90 plus 37. 180 minus the sum of 90 and 37. The sum of 90 and 37 is 127. And when that is subtracted from 180, the answer will be 53 degrees. The reason is sum of angles in a triangle. We were able to get these angles because we now know that an angle formed by a semicircle is equal to 90 degrees. An angle formed by a diameter in a circle is always equal to 90 degrees. In our first theorem for today, we talked about angles formed by a semicircle. In the second one for today, we have angles in the same segment. Angles in the same segment. Angles in the same segment are equal. We had said earlier that the line drawn from one end of the circumference of a circle to another point is called a chord. And a chord divides a circle into two segments, the major segment and the minor segment. If a line is drawn from one end of this chord to touch the circumference of the circle and comes back to the other end of the chord, an angle is formed here. I said, if a line is drawn from one end of the chord to touch the circumference of the circle and come back to the other end of the chord, an angle is formed here. If you draw another line from this same spot of the chord to touch another part in the circumference and bring it back to the other end of the chord, another angle is formed here. If this angle is lettered A and this angle is B, A and B are in the same segment. A is equal to B. A is equal to B. If an angle is formed here, which is drawn from one end of a chord to the other end to touch one part of the circumference, and you draw another line from one end of the chord to touch another part of the circumference, and bring it back to where the chord ends, the angle formed here is always equal to the angle formed here. They are said to be in the same segment. I have another circle here. If I draw a line from one end of the circle to touch the circumference and I bring it back to another point, I have just formed an angle here. If I draw another line from this same end down to touch any other part of the circumference and back here, the angle formed here will always be equal to the angle formed here. If this is x and this is y, x is equal to y. X degree is equal to y degree. X and y are said to be in the same segment. X and y are said to be in the same segment. I have another example here on the board, and in this example we were asked to find the lettered angles in the figure below. In this example we are asked to find the lettered angles in the figure below. The lettered angles were R, P, and Q. The lettered angles were R, P, and Q. How will the knowledge of these angles in the same segment help me to find R, Q, and P? You can see from this diagram that R is in the same segment as Q, like the theorem here says. Q, X is equal to Y, A is equal to B. Even if an angle is formed here, if this part is labeled as B and this other part is labeled as C, B degrees is also equal to C degrees. These two angles are said to be in the same segment, while these two angles are said to be in the same segment. How will this help me to solve this question? It is obvious that this angle and this angle are in the same segment and they are equal. So my first letter to be gotten here is P. P is equal to 28. And the reason is same segment. Yes, I know that R is also equal to Q, but I have to find the value of one of them first so that I can relate it to the other. P has now been found to be 28 degrees. How will this help me get R? I was told that this angle here is 83. With this 83, I can get this angle because they are in a straight line. They are on a straight line rather. I can label this part as V. In order to get V, I would say 180 minus 83, and that is straight line. The reason is that both angles were on a straight line, and 180 minus 83 is equal to 97. So this part that I labeled V is 97. Now that I have that part to be 97 and I already had this part to be 28, it becomes possible to get this R. Because, like I said earlier, if you know 2 points or 2 angles in a triangle, then it is possible to get the third side. This is a triangle. No matter how small it is still a triangle. So 28 plus 97 subtracted from 180 gives the value of R. So I write that R is 180 minus 97 plus 28. 180 minus 97 plus 28 is 125. 97 plus 28 is 125. And when 125 is subtracted from 180, the result is 55 degrees. The reason here is sum of angles in a triangle. These reasons carry their mark in any standard examination. Now that I've found R to be equal to 55, then it is possible to get Q, because we had said that Q and 55 and R are in the same segment. So therefore, Q is equal to 55 degrees. And the reason is same. So we have just found the values of the lettered angles R, P, and Q. We got P first because P was related to 28 according to this circle theorem. So P was found to be 28. We knew P as 28. In order to get R, we had to find this other part of this small triangle you can see here. And in order to get this part, we subtracted 83 from 180. When we did that, we got 97. When we found this part to be 97, we added it to 28 and then subtracted the result from 180, and we got R as 55. When we got R as 55, we then related it to Q, because R and Q are also in the same segment, like 28 and P. So Q became 55. And that was how we were able to find the three letters of that example. We have another example written on the board, and I must tell you that most times in circle geometry, one or two theorems can be superimposed in one question. So expect to see other theorems that you had learned in your previous classes in a question, and try as much as possible to recall them, because it might be helpful in finding the area that you are asked to. So in this example, we were told that CE is a diameter. The question reads, in the figure, line CE is the diameter of the circle. Line CE is the diameter of the circle. A, B, C, D, E. The circle was lettered A, B, C, D, and E. If A, B, C is 127 degrees, we were told, or were asked to find A, C, and E. The angle formed here. A tiny angle formed here. Now, this information that CE being the diameter of the circle reminds us of our semicircle theorem, which says that an angle formed by a semicircle is a right angle. Like we said earlier, if a line is drawn from one end of the diameter to touch the circumference and back to the other end of the diameter, the angle formed is 90 degrees. Now if you notice, the line formed from E drawn to point D and back to this point C is 90 degrees. Therefore, EBC is equal to 90 degrees. The reason is semicircle. You can see that theorem, semicircle, was involved in this particular question. Now that we've known this part to be 90 degrees, there's something I still want you to notice in this question. That there is still a cyclic quadrilateral in this diagram. We had said that a cyclic quadrilateral is a four-sided figure whose vertices touch the circumference of the circle. I want you to notice something. I want you to notice that there is a cyclic quadrilateral in this question. We had said that a cyclic quadrilateral is a four-sided figure whose vertices touch the circumference of the circle. The cyclic quadrilateral here is A, B, C, and D, neglecting this line ED. Without this line ED, you can agree with me that this is a four-sided figure. And we had also said that opposite angles of a cyclic quadrilateral are supplementary. In our first video class, we discussed the properties of a cyclic quadrilateral. We said that an angle formed at one end and the other part of the cyclic quadrilateral sum up to 180 degrees. So the angle formed here added to the angle formed here sum up to 180 degrees. So if this part is 127, this part ABC will be gotten by subtracting 127 from 180. So we write that ADC, the angle there is 180 minus 127. And if you subtract 127 from 180, you will get a 53. So the angle here is 53 degrees. The angle here alone is 50 degrees. But remember that we had gotten the angle, the line was drawn from here to this point, and we had gotten the entire angle here to be 90 because of the diameter that was formed here. So we had gotten this part to be 90, and we now know this part to be 53. It is possible to get this small part. This small painted part can be gotten by subtracting 53 from 90. I take that again. The entire angle EDC is 90, and we had gotten ADC to be 53. So to get this part that I shaded, we subtract 53 from 90, and we name that part as E, D, and A. E, D, A. So E, D, A is equal to 90 minus 53. If 90 subtracts 53, the result will be 27 degrees. So this part painted has now been found to be 27 degrees. And if you observe, 27 plus 53 will give the entire 90, which was gotten from the fact that EC was a diameter. It was gotten from the fact that EC was a diameter. So now that we know this part as 27, how will it relate to this part that we're looking for? Remember, this whole question says that we should find this angle here. This question says we should find this angle here. If you notice, this painted part and this part that we were asked to find are in the same segment. It was a line drawn from here to one end of the circumference and back to this point. And another line is also drawn from here to the other end of the circumference and back to this point. So the angle formed here is in the same segment as the angle formed here. Therefore, the angle formed here is equal to the angle formed here. And that is what we were asked to find. Angle ACE is now equal to 27 degrees. And the reason is same segment. So it was not possible for me to get this answer if I had not known certain properties of a circle that was discussed earlier. One of those were that the angle formed by a semicircle is equal to 90. And the other one that was also relevant in solving this question was that opposite angles of a cyclic quadrilateral is 180. So we were able to use those and get the required AC. I want to also remind you that we got this angle by relating the 127 given to this part as opposite angles of a cyclic quadrilateral. We knew that that part was 53. We also knew that since this line EC is a diameter, then the angle EDC is 90 degrees. Now that we know that part that's 90, we subtracted 53 from 90 to get this part, which is 27. And this part 27, EDA, is related to the required ACE according to this particular theorem, which is angles in the same segment. So therefore, the angle that we were asked to find, ACE, is 27 degrees, and the reason is that they are both in the same segment. We have another property of a circle here, and that is the tangent to a circle. We had earlier mentioned that an angle formed at a semicircle is 90, and we had also said that angles formed in the same segment are equal. In this third property of a circle, we have to first of all understand what a tangent is. We had said that a tangent is a line drawn to touch one point in the circle. A tangent is a line that touches just one point of the circle. When a straight line is drawn from one point to another, and that straight line touches one point in the circumference of the circle, that line is called a tangent. There are certain properties that a tangent has in a circle, and one of those properties is that a tangent to a circle is perpendicular to the radius drawn to its point of contact. It says that a tangent to a circle is perpendicular to the radius drawn to its point of contact. Perpendicular here means that the angle formed there is 90 degrees. So what this property of this tangent is saying, that if I draw a line from the center of the circle to the point of contact, that the angle formed there is always a 90 degree. So the property of this tangent is that a tangent to a circle is perpendicular to the radius drawn to its point of contact. If this line had been drawn somewhere here, and I draw a line from the center to that point where the line touches the circle, the angle formed there will be 90 degrees. So I have an example here written on the board, and the example here says that the tangent from a point T touches a circle at R. If the radius of the circle is 5 centimeters and T is 13 centimeters from the center, that I should calculate line TR. In other words, we are asked to find the length of this line TR. If you notice, TR is a straight line and it is drawn to touch one point in the circumference of the circle. So TR is said to be a tangent to that circle. Now, the question says that the tangent from a point T touches the circle at R if the radius of the circle is 5 centimeters. Yes, I could have drawn this radius from here to this point. Could have drawn it from here to this point. But because of the sake of this property, this perpendicular property, I drew it down to the point where it touches the tangent. And we had said that if a straight line is drawn from this point to this point, that the angle formed here is a 90 degrees. If the radius of this circle is 5 centimeters, it means that OR, which represents the radius, is 5 centimeters. And T, they said, is 13 centimeters from the center. Therefore, this T down to this place is given as 13 centimeters. We are now asked to find the length of the line TR. Now, when I see a question that has a 90 degrees angle, what comes to my mind is a Pythagoras theorem. And in a Pythagoras theorem, the square of the length of the hypotenuse is equal to the sum of the squares of the other two sides. So OT here represents the hypotenuse of this right angled triangle. So I will write that by Pythagoras theorem, OT square is equal to OR square plus TR square. By Pythagoras theorem, the length of this side, the square of the length of this side is equal to the square of the sum of the square of the length of this side and this side. So 13 square is equal to 5 square plus TR square. So I write that 13 square is equal to 5 square plus TR square. So on the other side of the board, 13 square is 169. 5 square is 25. Plus the required TR square that we're looking for. If I take 25 to meet 169, I will have 169 minus 25 to be equal to TR square. If you do your check, 169 minus 25 is 144. And that is equal to TR square. Now, to get the value of TR, we find the square root of 144. And if you do that, you will get a 12 centimeters. Therefore, line TR is equal to 12 centimeters. We have used this property of a tangent, which says that a tangent to a circle is perpendicular to the radius drawn to its point of contact, to help us find the length of TR. We got TR because we understand that the angle formed here is a 90 degrees and the triangle formed is a right angled triangle. We used Pythagoras theorem to find the length of TR. We said that OT square, which is the hypotenuse, is equal to OR square plus TR square. OT is 13, OR is 5, and TR was what we were looking for. We found 13 squared to be 169, 5 squared to be 25, and we left TR as TR because that is the length we are looking for. We took 25 to the other side and we had 169 minus 25 to be equal to TR squared. 169 minus 25 gives us 144, and that is still equal to TR squared. TR became the square root of 144, and that is 12 centimeters. Then we have found the length of TR, and that is 12 centimeters. We have another property of a tangent. We had earlier talked about a line drawn from the center of a circle to touch the point of contact to a tangent being perpendicular to it. In this situation, we have that the angle formed by a chord and a tangent is equal to the angle formed at the opposite or alternate segment. If we have a segment and we have a chord drawn to touch the point of contact of the tangent and the circle, an angle is formed here. This angle is always equal to the angle opposite that chord, or in the other segment of that chord. This angle is formed at the minor segment of this chord. This angle is equal to the angle formed on the major segment of the chord facing the chord. So this angle and this angle are said to be in an alternate segment and they are equal. So if this angle is A and this angle is B, then A is equal to B. I take that again. An angle formed by a chord and the point of contact to a tangent is equal to the opposite interior angle. And these two angles are said to be equal and they are in an alternate segment. Similarly, this is another chord. It forms an angle with this tangent here. This angle here is equal to the opposite interior angle here. So if this angle is labeled X and this is labeled Y, X is also equal to Y degrees. So X degrees is equal to Y degrees. Same way A degrees was equal to B degrees. Their reason is alternate segments. I have an example here written on the board, and the example is a very simple one. It says in the figure below, TS is a tangent to a circle PQRS. TS is a tangent to a circle PQRS. If line PR is equal to line PQ and angle PQR is 117 degrees, calculate RST. Calculate RST. Calculate the angle formed at S when you trace from R to S and to T. If you notice, we are looking for this angle formed by the chord and the tangent. And we had said that this angle is equal to the opposite interior angle if this line was not drawn in the question. This angle is equal to this angle. But I don't know this angle. So I have to calculate this angle from the information given to me. I was told that this angle here is 117. Now, another thing to notice here is that there is a cyclic quadrilateral in this question. There is a four-sided figure whose vertices touch the circumference of this circle. If I eliminate this line, I can see the four-sided figure. This is a four-sided figure. This is a cyclic quadrilateral. And remember the property of the cyclic quadrilateral, which says that opposite angles of a cyclic quadrilateral are equal. So this angle here is equal to this angle, is supplementary to this angle here. Or this angle here added to this angle here give 180. So I have this angle here to be equal to 63. How do I write that? I say solution. Angle RSP is equal to 180 minus 117. If I do that, I get 63. The reason is cyclic quadrilateral. Now that I've found this part to be 63, remember there was a straight line drawn from here to this point, and we were told that these two lines were equal. That they are equal sends a message to us. It tells us that this is a kind of a triangle called an isosceles triangle. And in an isosceles triangle, the base angles are equal. This part is 63, it makes this part 63, because this angle here is the same as this angle, according to the property of an isosceles triangle. So I also write that PRS is equal to 63 degrees. The reason is base angle of an isosceles triangle. Now that I have this part to be 63, I can get this part, because this PRS is a triangle. And like I've always said, if you know two sides, two angles of the triangle, you can always get the third side of the triangle. So angle RPS can be gotten from subtracting the sum of 63 and 63 from 180. So I write RPS to be equal to 180 minus 63 plus 63. If I do that summation, I'll get 126. 180 minus 126 is 54. So I have found this angle here to be 54. Remember, you must always indicate the reason that you subtracted this from 180, because sum of angles in a triangle is equal to 180. Now that I've found this part, I can now relate it to the required part that I've been looking for. So this part is equal to this angle. Therefore, angle RST, which is what we're asked to find, is equal to 54. 54 is related to this angle from this theorem that we have learned here. 54 is equal to RST because the angle formed by a chord and a tangent is equal to the angle formed at the opposite or alternate segments. So I write that RST is equal to 54 degrees. The reason I have to always put is alternate segments. These laws are easy to recall. These laws are always easy to remember. You can as well check these laws out in your textbook. You can also draw a perfect circle and confirm these laws by measuring the angles formed using a protractor. We had learned earlier that the angle formed in a semicircle is 90 degrees and the angles in the same segment are equal. We also understood properties formed by the tangent of the circle. I'm going to give you questions, and I ask that you do these questions like you've always done, screenshot them and submit to the email address that I'll send to you later. Thank you and God bless. The assignments are written on the board, and the first one says that in the figure above, SRT is a tangent at R to the circle center O. If RPQ is 36 degrees, find A, TRQ, B, SRP, and C, PRT. In the figure above, SRT is a tangent at R to the circle center O. If RPQ is 36 degrees, find TRQ, SRP, and PRT. The second one says, find the value of the lettered angles in the figure below. Find the values of the lettered angles in the figure below. The figure is drawn there. You're asked to find T, Q, R, U, V, and S. You have to find each of these letters. The third one says a point P is 6.3 centimeters from the center of a circle, and the length of the tangent from P is 5.6. Calculate the radius of the circle. A point P is 6.3 centimeters from the center of a circle, and the length of the tangent from P is 5.6 centimeters. Calculate the radius of the circle. And the final one is a circle drawn, as you can see. It says in the figure above, TY is a tangent to the circle TVS. If SVT is equal to 48 degrees and VS is equal to ST, what is VTY? In other words, find the angle VTY, knowing that SV and ST are equal. So if you can detect what kind of triangle that is, you will be able to solve that question. When you're done solving this question, please screenshot and send to my email address, which is anekevictor16@yahoo.com. anekevictor16@yahoo.com. The WhatsApp number is 07039371313. 07039371313.